Hi, good morning, and thank you for joining this live streaming webinar. So I appreciate you accepting my personal invitation, and we're here. So I'm going to talk quite fast and go quite quickly because really I have FoodSense Generation 4 in front of me. Rather than sort of lots of chat, I'll do demonstrations. I'm going to do quite a challenging sample this morning. I'm going to do Carolina Reaper powder, but I will do some easier things as well. But that said, let me stop talking. Well, I will talk, but let me kind of go through a few slides, set the tone, and off we go on some demonstrations. So thank you to FoodSense Generation 4 live streaming webinar. FoodSense Generation 4 is I think, a very easy to use, rapid detection for food ingredients like the Scoville heat, or food quality like the Scoville heat units of things like chilies. Today I'll do chili powders and a mild chili sauce. The background to this is really, um, if you look at the medical world, now I know we're here to talk about, food production and food quality, but if you look at the medical world, once upon a time they would have centralized laboratories, and people would send their samples to the centralized laboratories. When I say samples, um, they'd go to a doctor, they would have their blood drawn, the blood would go back to the centralized lab. Um, they would go onto a robotic system, and eventually a kind of result would come back to the patient. Now, when you're trying to control something like diabetes, having, a 2 or 3 or 1 week delay, maybe a month delay, it's not helping you control your diabetes. And it's the same in food quality as well. That, I mean, in particular in India, I know that people are kind of, I'm not saying so, that they're required to get the Scoville heat units done on their samples sometimes, but of course, um, there can be an expense and a delay based on that. So, like, so in the food, in the medical industry, there used to be a very cultural centralization of test. Those instruments became smaller and smaller, and eventually it actually became handheld and palm size. And even now, in the world of diabetes, you will see people wearing these sensors. So it tells you that there's a shift in the world of medical health where actually everything's become smaller and actually become what we call point of need testing. So what can we learn from the point of care? What can we learn from the medical industry? Well, we can learn from the medical industry. If I want to control something or I want a lower cost of test, then having small electrochemical sensors to measure, in this particular case, the glucose in blood is not a bad way to go. Now, what I want to do for a second is I want to stop sharing for a second. I just want to share a slightly different camera with you and just emphasize this point, because I think when you're in the food industry and you've got a kind of a technical background, a PhD kind of background, you're very used to kind of very scientific instruments. And this is also, but actually, if you really want to scale test and make test easy, sometimes the instruments, they're no less scientific, but they're easier to use. So we're quite used to having quite hard to use instruments with lots of calibration, etc. But if I take, a glucose meter, if I want the glucose meter to be effective, it's got to be easy to use. So let me take a glucose meter. Let me do a sample preparation for you. There's a drop of blood. Get that blood out with me now. Right. And then I'll put the blood onto the meter, and then about 5 seconds later we should get a result. In fact, I've got it. I've just had my breakfast, actually, so that's really interesting, actually, because I just had my breakfast, some what we call Weetabix and a banana, and my blood glucose is actually 168 milligrams per deciliter, which is approximately about 8 millimolar, where normal glucose is actually 5 millimolar. So I'm actually high. Right. The only reason I showed you that then was just to make this point that that is simple to use. It doesn't require, I mean, we both have PhDs. It doesn't require a PhD to run an instrument like that. Um, and that's the point. You can actually scale test when you make it easy to use. So I'm just going to go back to this point now. So the whole philosophy that we've got running at ZP is actually, what can we take from the medical industry? What works? What does it add value? And, can we translate it to the food industry? And that's what the FoodSense Generation 4 is all about, is actually just making test rapid, lower cost, and much easier to do. And that's what's kind of come to the FoodSense Generation for. So what I'm going to do now is do a quick demonstration. So I'm just going to stop sharing for a second. I'm actually going to go to my camera here. And you can see that. All right, so I've got the FoodSense Generation 4. I've got a chili sensor. I'll put that on like that. I'm going to, first of all, just do a super simple sample just to kind of get us going. And then I'll do more complicated samples as we go forward. So let me just do a... Now, I think in particular in places like India, the samples tend to be more like chilies and chili powders. So I will do a more complicated sample in a minute. This is just to kind of give us a baseline, because it's a simple sample to prepare. I can do it, but I can sort of show you that, at its fastest, we're more like a glucose strip than we are like a scientific instrument. So I've got a bit of sauce in there. I will take some sauce. I'll take 100 microliters of the sauce, which I've just done. I'm going to dilute it 10x in buffer. Which I've just done. I'm just going to pull a vortexer into shot just so you can see that I'm using a vortexer. It just really speeds up sample prep, and I also think it leads to more accurate results because there's so much vibration able to be done by that machine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, I'll just take that out of the shot for a second. Now I'm going to grab 50 microliters of the sample. So here it goes, 50 microliters. So it's much more similar to that medical diagnostic I showed you earlier on. Sample was in this particular case is rapid to prepare. Doesn't require much sample. And what I will now do is I'm just going to give this a name. Tabasco, done. Yeah, Tabasco 11, right, done. Continue. I did a 1 in 10 dilution, so I'll choose 1 in 10, and I'll start the measurement, and off it goes. And then it also fits that other part that I was talking about, that it's actually rapid. This is rapidly grabbing data in real time, and then it will send the data to the cloud, it'll process it. That's like a perfect answer. Right, now I want to show you the next bit, which is, this is really important for sort of traceability aspects. So I'm going to share my screen with you for a second. And I will go to here. So I'm just going to do a quick refresh in the cloud. So let me just do that. Quick refresh here. Right, result jumps up into the cloud. There's the result. We can come in here now. This is the bit that I think is really, with HPLC, you very rarely get any kind of raw signal. So you can't really kind of challenge it because you have no, let's say, data or evidence to challenge it upon. People just accept it as fact, that is it. But what we can see here is I can see what's called scan 1. I can see scan 2. Scan 2 then shows us peak 1 for capsaicin, peak 2 for capsaicin, peak 3 for capsaicin, and then we analyze that peak 2, and we get the peak height, and then we turn the peak height into micromoles of capsaicin, but actually then we turn it to Scoville heat units because that's what the kind of units that people are more familiar with in this industry. And Tabasco sauce is shipped at about 5,000 Scoville heat units. Now, what I want to do is also show you that you can actually export this as a PDF. If you want some sort of, you want to kind of have a record of this. It didn't have to just be in this cloud system. You can almost produce, I could have put a signature on that as well. I can produce almost a certificate of analysis that I've got my source, date, operator. I could have put some reviews or some comments in there. I've got the raw signal and I have the result all saved. So it's a kind of very nice workflow finishing not just in some emailed number, Scoville heat unit was this, or, and you get certificate of analysis from HPLC, and this will also give you a certificate of analysis, but more than an HPLC, it actually gives you the genuine evidence as to this is capsaicin, and this is how we measured it, and this is the result that we actually got. Now, what I'm going to do next is go to a tougher sample now. So I'm just going to stop sharing for a sample. No, sorry, for a second. I'm going to go to this camera here, and I've got some Carolina Reaper powder. Now, powders are very rarely at the heat that people think they are. So what I'm going to do is, now what I've done here is I've got 100 milligrams of powder in 900 microliters of buffer. So that's a 1 in 10 dilution. I only prepared it a few minutes ago, but it was easy. It was quicker to prepare it than to prepare it and weigh it out in front of you now. But that's a real slurry. That's thick, actually. So what I'm going to do is I'm going to take this sensor off. I'm going to throw this one away. I'm going to bring in a sensor. Now, I'll bring in my vortex, and I'm just going to vortex this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. All right, there we go. Right. By the way, I will send you a recording of this afterwards, so there's no need to, have to remember everything we did. I'll send you a recording shortly. So what I'll do now is I'm actually just going to bring my app in for a second. Right. So this is, don't be disappointed if this Carolina Reaper powder is not Carolina Reaper, is not as hot as they say. It's no criticism of the supplier of this material, by the way. I'm in no way criticizing them. It's just people have these kind of they don't do the testing, basically. Nobody's really testing, actually. Or if they are testing, it's kind of, there's no evidence as to where that result really came from. I got a suspicion that sometimes the testing that people say is happening is actually they're just using the internet to go and find out what the internet thinks the hotness is, and then just putting that on the label. All right, so what I'll do now is I'm going to take 50 microliters. I'll put it on the sensor. So you can see it's quite a brightly colored sample. I'll go continue. I'll choose the 1 in 10 dilution. I'll hit start, and off it goes. So it's grabbing. Now there's gone a very flat line here. That tells me something instantly. Don't forget, this is Carolina Reaper powder. This is a flat line as well. So it's Carolina Reaper powder, and I'm saying don't be disappointed if not as hot as people sort of think these things are. Don't forget, it's a very variant crop. So what we've got here is it says upload complete, too high, dilutes more. So it's guiding me, see, because I know that this is actually a very hot sample. So I know it's hot, and in fact, it's going to need some dilution. So what I'll do is I'll take that sensor off. I will grab another little vial. I'm just going to vortex the sample up very quickly, because I just want it homogeneous before I actually, because what I'm going to do is I'm going to take 100 microliters of it. So let me just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just to get it homogeneous. So then when I take my 100 microliters, which I've just done, I'll put my 100 microliters in there. And now I'm just going to put 900 microliters of buffer in with that. So I do a 1 in 10 dilution. Now, don't forget, it's already a 1 in 10 dilution. So it's actually going to become a 1 in 100 dilution. Just get a bit more buffer. So I've got my there we go. Right, so I will now vortex this. Right, so here's the sample I'm about to vortex. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Right, there's my sample. Bring the vortexer out. I'll put a fresh sensor on here. Close that up. I will get 50 microliters of that sample. All right, 50 microliters has gone on there. Right, bring my app in. On my app, I'll go done. I'll go, now I know this is now 1 in 100, so I'll just put 100 into that name so that I can find that later on. Continue. I must choose 1 in 100 now because the app is smart and I want to give you the result of what's actually in the sample, not, and it's taking account of all the dilutions by doing that. So I'll do that and let it run. Again, it fits that glucose. I can see it's flatlined again, so it's still, and it's just about flatlined that time as well. So, and it says it again. It says too high, dilutes more. This is no problems. I was expecting this because it's a Carolina Reaper, but it tells you that a 1 in 10 dilution, and we can look at the raw data in a minute as well. But a 1 in 10 is not enough. A 1 in 100 is not enough. And I wasn't surprised. But I wanted to kind of do I wanted to do that simple sample to get us going. And then I wanted to do a more complex sample. So I'm just going to do now is just vortexes 1 in 100 to homogenize it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that's homogeneous. I'll take 100 microliters of it. All right, done. Put the 100 microliters into here. Now that is 1 in 100. And now I'm going to take 900 microliters of buffer. So here goes. And do a dilution on that. So now this is actually a 1 in 1,000. And it's, the fact that I've actually diluted this 1,000 times gives you a sense of how much capsaicin's in this. I'm just going to vortex this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Right. I'll put that aside. Right. So I put that aside. Now that's my 1 in 1,000. You've got to understand that I've got to kind of keep an eye on things because I'm doing all this fast. I'm talking to you at the same time. There's quite a complexity to this. Not complexity, just talking and not, talking and doing at the same time. Right. Put a sensor in here. Right. There's my sample. And right, so I've got my sample. 15 microliters onto that. Right, now I'll hit done. 1 in 1,000, good, back. Continue. I'll choose 1 in 1,000 here. And then I'll hit start measurement. All right, so the peaks are smaller now because of course this is actually diluted 1,000 times. But it's also credit to the hotness of this kind of material. So there we are. So we got a capsaicin score now of not 2 million, but 205,000. I'm not criticizing Carolina Reaper, but it's worth knowing that there's that people will label things up, and then they're sometimes disappointed that they're not quite the scoville heat units that they're actually expecting. But we've just been doing this quite a while now, and actually things are not as hot as people would otherwise think, or at least they're not accurately being reported. I think what's going on here is this is a industry with low margins. People want to report scoville heat units, but they're actually doing it by essentially guessing. Is one of the things that's actually going on here a little bit. Now, what I want to do now is I just want to kind of share my screen. So this is the, let's say, signal for that chili sauce, and you could cut quite a mild chili sauce. It's only 5,000 scoville heat units. You can see that signal when we did a 1 in 10 dilution. So let's go back now and look at these reports. We'll just do a quick refresh. Here it goes. Right, so we've actually got the Carolina Reaper 1 in 10. Let's have a look at that. So this is when we did a 10 times dilution on that powder. That was the first sample. And you can see it's very flat here. And in fact, it's, you know, it's flat. So it's basically said, okay, this is too much, there's too much sample, or sorry, it's too much capsaicin in this. And it's actually thrown an, I wouldn't call it an error. It actually gave us guidance and said, actually, you need to dilute more. So then I did the 1 in 100. So that was the next one I did. Now, it's probably worth noting, actually, we've only been doing this about 21 minutes, and we've already done at least 4 tests. So here's the 1 in 100. You can see actually a really intense peak, in fact, and that's flatlined as well. And then we did the 1 in 1000. So let's have a quick look at that guy, 1 in 1000 here. So a nice sharp peaks. Look at these nice sharp peaks. And nice sharp peak in the same order of magnitude as that Tabasco sauce sample I did, right? Nice same order of magnitude, but a diluted 1,000 times. So, and in fact, you know, when you think about it, in fact, you know, the Tabasco sauce was about 5,000. It had a peak height of 6. This is actually 200,000. We've got a peak height of about 3, and came back at 200,000. So you can sort of see the maths that's going on here, that, you know, we're timesing by 1,000 to take care of what's called the dilution factor. And then if you're happy with that, you can export it, and you've got your kind of traceability on this. Now, there may be a legal requirement or a statutory requirement in some countries to still do HPLC testing, but of course, at least now you can either verify on the HPLC or not verify, but you can actually do a lot more testing and only send out on occasion samples for HPLC testing. So now what I want to do is just go back to my slides here to kind of remind me of what we're up to. So I did 4 tests. Sample prep was quite straightforward. I want to sort of summarize by saying, so at ZP, we're not trying to displace or replace any incumbent technologies. What we're trying to do is say, if you want to control and improve things, then you probably need rapid, low cost, easy to use tests. And so that's what we've done in the chili industry. This instrument, I mean, you've seen me run it this morning. It's much more robust, lower cost, easy to use than any other system. And you know, the turnaround time on the results is almost instantaneous. You saw how quickly I was doing that. If you do have any questions, any further questions, I'll drop you a recording of this shortly. I'm going to jump into my next meeting, but if you do have any questions, you'll see an email come from me shortly with a recording of this. Okay, thanks very much.